Okay, this is term 3 week 2 chemistry AMS. Which of the following, it's very easy, which are not properties of noble gases? Of course, they're monatomic, that's true. Inert, they're true. Column 18, of course, that's true. Do they decrease down the group? Obviously not, it should be increase. And are they highly reactive? Of course not. Okay, question 2. Which of the following have a stable electron management? Stable, yani it's a noble gas, right? Okay, so you have to pick the ones which are noble gases, and helium is a noble gas, krypton, neon, they're noble gases. أكيد aluminium and oxygen are not noble gases. Which of the following is an unreactive monatomic gas? أكيد, again they're saying noble gas. Okay, and their atomic number is 2. Again, that's helium. If you look at helium, the atomic number is 2 and the mass number is 4. Question 3, 4. Whoa. Okay. Which of the following is true about a compound that has low potential energy? If it has low potential energy, that means it's stable. That means it doesn't have the potential to change into any other compound, so it's stable. Question 5. Which reactions occur spontaneously? Spontaneously. Remember the displacement reactors? It was always a halogen, okay, plus halide, right? The halogen was always the one that has 2, and the halide was always has a 2 minus. Okay, so for it to occur spontaneously, remember that the halogen has to be more reactive than the halide, and the halogens, if you look at them, they're in group 7. They're F, Cl, Br, I, and then astatine at the bottom. Okay, FKB. Okay, the more reactive ones are always at the top, and remember that the halogen always has to be the more reactive one. So let's see here, Br2. Br2 is the halogen, okay, and then F minus is the halide. Br, F. The halogen is supposed to be above the halide. In this case, Br isn't above F, so this is wrong. And then I2 and 2F minus. I is down here, F is here. Which one's the halogen? It's I2. So I2 is supposed to be above the F, but I is actually under, so you cross it out. Cl2 plus 2Br. Cl is up here, Br is here, and since Cl is the halogen, it should be above Br, and in this case it is, so we take it. Br2 and 2I minus. Br should be above I, it is in this case, so we take it. Question 6. What is the state of hydrogen under normal conditions? Gas. I mean, it's obvious. It's always a gas. Hydrogen, 99% of the time it's a gas. Which ones are the halogens? Fl, FCl, Br, ATI, FKB, group 7. Okay. Okay, these gases, what do we call them? Noble gases. This is very simple. Obviously they're stable. Their electrons are stable. And if they form the compound, they form reactive compounds. Remember that. Noble gases, if they form compounds, it would be a reactive compound. Okay, NaCl is built is a very stable ionic crystal because it's built of charged particles that have a noble gas configuration. For example, NaCl, right? Na plus Cl minus. That means it loses, right? So it was 11 and 23. Okay, Cl was 17 and 35, if I'm not wrong. Yeah, wait, let me go to this. Cl. Yeah, 17 and 35.5, or 35 doesn't matter. So once this Na loses an electron, it will have 10, like neon. Okay, and Cl, once it gains 1, it's gonna have 18, like, I don't know, let me see, noble gases. It's gonna have 18 like argon. It's gonna come like argon. So once it loses, it becomes like the noble gas, and once this gains, it becomes like the noble gas. Okay, so sodium will lose 1 electron and chlorine will gain 1 electron. No, that's obvious. Na plus, Cl minus. Question 10. Alkaline metals are soft and malleable. They form +1 since they're group 1, and obviously they're good conductors of heat and electricity. If it's a conductor, that means it conducts heat and electricity. It's easy. The electrical conductivity of metals is caused by the presence of loose electrons. Loose meaning it moves around. So why does it conduct? Because it has loose electrons. The electrons in the atom move around. So like you would have, this is a nucleus over here, it's positive. You have the electrons around it, yeah. If it conducts, that means these electrons are loose, so they keep on moving all around. Question 12. Alkaline metals are very reactive because they're group 1, and if they form compounds, they're stable compounds. Like for example, we said, you know, the group 1 and Na, for example, the alkaline metals are Lena, Crib, Cis. These are the alkaline metals. Okay, so for example, Na plus Cl is NaCl, right? So it forms a stable compound because we know NaCl is stable. Okay, so if they form a compound, it's going to be a stable compound. Unlike noble gases, if they form compounds, it's reactive. An ionic bond is formed when an electron is transferred permanently to another atom. Again, when you have Na and Cl, this loses the electron and this gains the electron, right? So, and the bond between them is ionic, because when you're losing or gaining an electron, it's ionic. So thus resulting ions attract each other, thus energy is released. You're always releasing energy whenever forming a bond. Okay, and a stable crystal is produced, and since it's stable, that means the potential energy will always be low, so it's obviously going to be decreased. If it's stable, that means low potential energy. Question 14. When a covalent bond forms, a pair of electrons is shared. If you say transferred, you get it wrong, because covalent means share, always. The product is a molecular substance. Okay, it's a molecule. If you want, you can say molecule, I think. Yeah, you can say molecule. Okay, covalent bond is when you have, hold on, take that back off. Covalent bond is when you have two non-metals. Okay, so obviously it will be molecular. If it's covalent, it's always molecule or molecule. Question 15, this is easy. Chlorine atoms share 2 chlorine, 2 oxygen, 2 nitrogen. They're all non-metals, so obviously it's going to be a covalent bond, so it's sharing always, okay? And since it has 7, it needs 8, right? This has 6, this has 5. To become 8 needs +1, so single, right? It's going to share 1. 6 to become 8 needs 2, so double. 5 to become 8, it needs 3, so triple. That's it. So chlorine shares 1, goes from 7 to 8, and it's single, covalent. Oxygen shares 2, 6 to 8, and then it's double, obviously covalent. And nitrogen shares 3, so triple. 16, okay, this is easy. So the noble gases, you know that the boiling points increase as you go down. So as you go down, they increase. So obviously, if you're starting from the top, it's going to be the lowest, which is 4.2. Then after, what comes after 4.2? 27.2. After 27 is 87. After 87 is 120. Pretty straightforward. And then again, for the melting points, same thing. If the boiling point is increasing, that means also the melting point is going to increase. So as again, for noble gases, the melting point and boiling point increases as you go down the table. So again, the lowest will be at the top, and it keeps on going higher. See, after 83 comes 116, 116, 161. It just goes up as you go down. However, I think this one's for the alkaline metals. Yeah, for alkaline metals, it's the other way around. So as you go down, it actually decreases for the alkaline metal. Okay, so it starts with the highest at the top, then it starts decreasing as you go down. Same thing here, highest at the top, then it decreases as you go down. Okay, question 18, it's not the last one, still more. Okay, you guys know the flame tests, and the flame tests, you memorize them. The red one always goes to lithium, yellow goes to sodium, and violet or lilac goes to potassium or K. Question 19. Okay, yeah, these ones you memorize them. Fluorine is okay. You have to know all of them are gases except bromine is a liquid. Remember, bromine exists as a liquid. That and it and mercury are the only two elements that can exist as a liquid. Okay, in the normal state, yani. Okay, Iodine and astatine are both solids. Okay. Question 20. They added AgNO3 and it became white, formed a white precipitate. If it's a white precipitate, remember it's chlorine. If it's yellow, it's I minus, and if it's creamy, then it's Br minus. Question 20. ما بدها تخلص هيدي. Question 22. 21 قصدي. The chemical formula of magnesium chloride. أكيد you just have to crisscross Mg2 plus Cl minus crisscross becomes MgCl2, and since it's metal non-metal, it's ionic bonds. And then phosphorus trichloride. Okay, I mean that's kind of obvious. Phosphorus P trichloride, that's Cl3, but you can still do it. Phosphorus is in group 5, so P3 minus, Cl minus crisscross PCl3, and it's covalent. It's covalent. Crisscross. Okay, crisscross. Oh, short. Okay, zinc reacts with. You have to do R and GR here. Okay, let's start with 0.109 grams of zinc. Okay, excess HCl, and collect the hydrogen gas. This is the equation over here. Okay, moles of zinc. Okay, you know moles, if you have the mass, it's N equals M over M, which is equal to 0.109 over the molar mass of zinc, which is 65.4. And if you do divide them, you should get 1.66, I think. Keeps on going. So you just round it to 1.67 times 10 to the minus 3. Okay. Part B, calculate the number of moles of hydrogen gas collected. Okay, so you're gonna look here. Since zinc and hydrogen, they both have the same coefficient, right? So that means obviously they're gonna have the same mole, same number of moles. Okay, so since we had 1.67 times 10 to the minus 3 for part A of the zinc moles, it's also going to be 1.67 times 10 to the minus 3 for the hydrogen moles. For part C, locate the syringe indicating the volume, right? The volume, and they're saying in cm cube. So always you have to know N equals V over Vm. Okay, and since we're talking about RTP, Vm equals 24. And we know the moles is 1.67 times 10 to the minus 3 equals the volume over 24. Cross multiply, you're gonna get, I think you're gonna get 0.004. I think, well, let me do on my calculator. 1.67 times 10 to the minus 3 times 24. You get, oh, hold up. No. You get, no, you don't get this. You get 0.04008. But this is in dm cube, right? So what if I want it in cm cube, like they're saying? In cm cube, it would be times 1,000, right? So I just multiply this by 1,000. So 1, 2, 3, it's going to be 40.08 dm cube. So we have to locate the syringe that's at like around 40, and it's going to be this one, okay? Question 23. Ya Rabbi. Okay, choose the heavier gas. Obviously the heavier gas will be the one that has a slower rate, so it will be gas X. Find the molar mass. Again, when you have velocities, you have to use V1 over V2 equals radical M2 over M1. V1, always put the lighter gas up, so 0.87 over 0.63 equals radical M2 over M1. So we have to take the mass of 0.63, which is X, so it's going to be X, over M1, which is the mass of the other one, the one that's down here, up here, which is hydrogen chloride, which is HCl. They gave us H is 1, Cl 35.5, so it's going to be 36.5. Now we have to square both sides to get rid of the radical. Okay, so it's going to be 841 over 441 equals X over 36.5. So X will just be this times 36.5. So you can do it 841 over 441 times 36.5, and you should get x equals 69.6065 whatever. أكيد they wanted 3 significant figures, so you just keep it 69.6. Arrange the increasing order of rate of diffusion. أكيد the fastest one, the one with the highest rate, will be the lightest one. Okay, so you have to just take a look. CO2 is 44, HCl is 36.5, and H2O is 18. So أكيد it's gonna be H2O at the top, HCl in the middle, and CO2 at the bottom يعني. And then for the last part, choose the lighter gas. أكيد since the colored stain is closer to B, then A will be the lighter gas because it reached here before gas B did. Okay, so gas A will be the lighter gas.